Hi everyone, so today we're going to be doing notes on section 5.3, which is solving systems using elimination. So we have talked about the other two ways of solving a system already, graphing, which was section 5.1, substitution, which was 5.2. Today we're talking about the last one, elimination. So go ahead and pause this real quick to write down the steps, and then I'll go over it with you. All right, so first thing you're going to do when solving using elimination. First, what do you think of when you hear the word elimination? Good. If you said something along the lines of get rid of, then you are correct. Elimination is like saying you're getting rid of something. So we're going to get rid of either the x or the y value to solve for the other one. So step one is to check if your equations have opposite x or y values already. So for example, if you have negative x and positive x, those are considered opposites. They'll cancel out. Negative 2y, positive 2y. Those are opposites. They will cancel out. So you always want to check first if you already have those in your equation, because it's going to save you a lot of work if they're already there. But if they're not, if you don't already have opposites, you'll move on to step two. And if not, you will multiply one or both equations by a number so that a variable will eliminate. So you'll decide if you're going to get rid of your x's or your y's, and then multiply one or both equations to get rid of that variable. Then, after you've done that, you'll add the equations together and solve for the variable that's left, either the x or the y. And then you'll have one of your values that you'll substitute back into an original equation to solve for the other variable. And lastly, you'll write your answer as an ordered pair. So it seems like a lot of steps, but it's really not too bad. So let's go ahead and look at the first example together. So 3x plus 2y equals 4, and 3x minus 2y equals negative 4. Are the x's or the y's already opposites? Good. You should have said yes, the y's are already opposites. We have positive 2y, negative 2y. The x's are close to being opposites, but one of these would have to be a negative to make it positive 3x and negative 3x. But since my y's are already opposites, this works out well. We can just add these two equations together, and the y's will cancel out. So when I do that, I add these together. 3x plus 3x equals 6x. The y's cancel. Equals 4 plus negative 4. It's like saying 4 minus 4, which is 0. Divide both sides by 6, and we get that x equals 0. We have half of our answer. Now from there, we need to plug this into either equation to solve for y. So plug in to either equation. Now it doesn't matter which one you pick. I'm going to choose the first one because it has all positive values. So 3 times 0 plus 2y equals 4. 3 times 0 is just 0. That cancels out. So I'm left with 2y equals 4. Divide both sides by 2, and we get y equals 2. There's the other half of our answer. And then we want to write, I don't know why my hand just paused on the screen. There we go. And we want to write our answer as an ordered pair. So 0, 2 is our final answer. So it's not too bad. Considering how many steps were written down, it's not too bad, especially when you already have an opposite x and y. All right, I want you to go ahead and try the second example on your own. So go ahead and push pause. And then when you're ready to check your answer, push play. All right, go ahead and check your answer for this example. You should have gotten 2, 3. So your x values are already opposites, 2x and negative 2x. So those will cancel out right away. And when you add these together, so you're only left with y values, which is what you solve for first. You get y equals 3, and then you plug it back into either equation. I chose to plug it into the first equation. If you chose to plug it into the second equation instead, you should have still gotten 2 as your answer. Because remember, saying that this coordinate point is the answer means it works in both equations. It is true in both equations. So it doesn't matter which one you pick to plug it back into. All right, let's look at another example. So looking at this, step 1, are the x's or y's already opposites? Good, you should have said no, they are not. They're kind of close, but they're not already opposites. So I have a couple of options here. The x values are negative 10x and negative 5x. So what number would I have to multiply the second equation by to make it the opposite of negative 10? Good, if you said negative 2, you are correct. So let's write the options. Eliminate x. So to eliminate x, multiply the second equation by negative 2. That'll give you negative 10x and positive 10x. Now our other option is to eliminate y. So to eliminate y, 3y and negative 6y, we'd have to multiply the top equation, so the first equation, by 2. Because it's already a positive and a negative, which is great, you just have to multiply it by the number. So this is where your own personal preference and your choice comes in. You decide whether you want to eliminate the x or the y. Me personally, I would choose to eliminate y because we already have one that's positive and one that's negative. But that's just my own personal preference. So that's what I'm going to do here. So the top equation, I don't know why I just drew parentheses around the second one. Sorry, ignore those. The top equation has to get multiplied by 2, and I'm multiplying the right side and the left side by 2. Ignore the parentheses on the second equation. So when I do this, I'm going to rewrite them down here. So 2 times negative 10x is negative 20x. 2 times 3y is positive 6y. Equals 2 times 1 is 2. Second equation stays exactly the same. Now my y's are opposite, 6y and negative 6y. So I can go ahead and add these together. The y's will cancel out. And I'm left with negative 25x equals 25. Divide both sides by negative 25. So I get x equals negative 1. If you feel more comfortable showing that step of dividing by negative 25, then feel free to do that. Then we're going to plug x equals negative 1 into either equation and solve for y. So again, doesn't matter which one you pick. I'm going to choose the first one because it has smaller numbers. It has a 3 and a 1 versus this 23. So I'm going to pick the first equation. So negative 10x, but I'm plugging in negative 1, plus 3y equals 1. Now some of you may ask, can you plug it into this one instead? After we multiplied it by 2, the answer is yes. I chose not to because the numbers are bigger and we have a greatest common factor. So I stick with the original 2. So this becomes 10 plus 3y equals 1. Subtract 10 from both sides, so 3y equals negative 9. And divide both sides by 3, so y equals negative 3. Now I have my x and my y, so my final answer is negative 1, comma negative 3. Next example, I want you to go ahead and try this one on your own. So again, you get to choose whether you want to eliminate the x values or the y values. So look at what your numbers are and decide which one you prefer to eliminate. You will get the same answer regardless of which one you choose. So go ahead and pause this, and when you're ready to check your answer, push play. Go ahead and check your answer. So I wrote the little note over here in green again, what your options were. So you could either eliminate x by making both of them 4x and negative 4x, or you could eliminate y by having 5y and negative 5y. I chose to eliminate x because it was multiplying everything by a positive number. But if you chose to eliminate y instead, you should have still gotten the same answer. And then plugging the y equals 4 back into either equation, I chose to plug it into the second equation just because the numbers were smaller. But if you plugged it into the first equation instead, your answer should have still been the same. All right, let's do one more example together. So if we look at this one, are the x's or y's opposites right now? Good, you should have said no. Neither of them are opposites. We have a 5 and a 2, and a negative 2 and a positive 7. Now looking at this, it's also not an obvious answer as to which one is going to be easier to eliminate. So I'm going to write this over here again. Now when I do these problems on my own, this stuff that I'm writing over here in green, this is what I do in my head, but I want to write this down for you to see so that when you go back and look at your notes later, you understand the thought process. So if we eliminate x, 5x and 2x, what is the smallest number that 5 and 2 both go into? Good, if you said 10, then you're correct. The smallest number that 5 and 2 both go into is 10. So we need to make them 10 and negative 10. Well, 10x and negative 10x, I should say. Which means we'll multiply one of them by 2 and 5 and make one of those numbers negative. Then if we want to eliminate y, what is the smallest number that 2 and 7 both go into? Good, if you said 14, you are correct. So make them 14y and negative 14y. So now it's up to you which one you want to choose to eliminate. Now for me personally, to eliminate the x's, I have to multiply them by 2 and 5. To eliminate the y's, I have to multiply them by 2 and 7. Just out of sheer simplicity, I would pick the 2 and the 5 because the numbers are smaller, but it is totally your preference. Some people may want to eliminate the y's instead because you already have one that's positive and one that's negative. Personal preference. You'll get the same answer either way. So I'm going to choose to eliminate the x values instead. So the top equation I have to multiply by 2, and the bottom equation I have to multiply by 5. That's going to make my x values 10x and 10x. But I need to make one of these negative. So again, personal preference. There are so many different ways to do these problems, and all of them are correct. I'm going to choose to make the 5 negative just because I have a little bit more room in front of it. That's the only reason. Honestly, it doesn't matter which one you make negative. All right, so let's go ahead and rewrite these. So the top equation, 2 times 5x is 10x. 2 times negative 2y is negative 4y equals 2 times 10 is 20. You need to multiply everything. Bottom equation, negative 5 times 2x is negative 10x. We're in good shape. Those are opposites. Negative 5 times 7y is negative 35y. 43 times negative 5 is negative 215. And now I'm going to add these together. So the x terms will cancel. I get negative 39y equals 20 minus 215 will be negative 195. You can also do this as 215 minus 20, and then you know the answer is going to be negative because you're subtracting the bigger number. That's how I did it in my head. I did 215 minus 20 and then made the answer negative. Then we divide both sides by negative 39, and we get that y equals 5. It goes in evenly, and you can use a calculator for that. So now that I have my y value, I still need to find x. I'm going to plug y equals 5 into either equation and solve for x. Now again, you can pick either of the two original equations or two of the new equations. I always say original because your numbers are going to be smaller. And using this theory, I'm going to go with the very first equation. So 5x minus 2 times y, which is 5, equals 10. So 5x minus 10 equals 10. Add 10 to both sides, and we get 5x equals 20. And then divide both sides by 5. So x equals 4. And now that we have our x and our y, we write our final answer as the coordinate point, 4, 5. So again, so much of these problems are personal preference. So I want you to keep that in mind when you're doing your homework today, and even when you check the next example that we're going to do, or that you're going to try on your own, is you may choose to use a different method than me or one of your friends or classmates, or differently than how I have it worked out on your homework that you're going to check. Because there are so many ways that you can do these problems. The main thing to focus on is that you get the same end result, because no matter how you choose to solve it, your answer should always end up being the same. So with that in mind, this last example, you're going to try on your own. Now again, look at what you need to have to eliminate the x's or eliminate the y's, and then choose which one you want to eliminate. So go ahead and push pause, and when you're ready to check your answer, push play. All right, everybody, go ahead and check your answers. So I wrote over here in the green, if you wanted to eliminate x, they needed to be positive and negative 10x. And if you wanted to eliminate y, they needed to be positive and negative 6y, because 10 is the smallest number that 2 and 5 go into, and 6 is the smallest number that 3 and 2 go into. I chose to eliminate y, partly because the numbers I multiplied by were smaller, but also because one is already positive, one is already negative. But again, if you chose to eliminate x instead, you'd still get the same answer. So I multiplied the top equation by 2, bottom equation by 3. When I added those together, I got x equals 5, and then I chose to plug them back into the first equation to solve for y, and ended up with y equals 2. So my final answer written as a coordinate point was 5, 2. So again, if you chose to do it differently or eliminate your x or plug your answer back into a different equation, you should have still got the same end result. All right, that is the end of our notes. Have a good rest of your day.